Okay, so I just want to go through a few questions that may come up and just give you an idea of how I think about each of these. There might be a bit of an echo with this video, so apologies, and also if the AC flicks on and off like that. So I'll try and keep it short and sweet throughout. So I'm just going to talk about how I'd answer each of these. So first up, we've got indices. Given that y equals 2 to the x, show that this can be written in this form. So the first thing that I'm thinking here, if y is 2 to the x, is thinking what 2 to the 2x plus 1 can be. So 2 to the 2x plus 1, we can actually write as 2 to the 2x times by 2. So here we've got 2 to the 2x times 2, which can also split up to 2, and then this one can be 2 to the x all squared. So that's like 2x, and then times 2. So in other words, this is 2y squared. So you want to be thinking about that in your head, but you're showing a little bit of how this breaks down. 17, 2 to the x, well, that's just 17y, and then this plus 8 is the same. So you want to physically show that, so then that implies that it can be 2y squared minus 17y plus 8, and that's equal to 0. So just going to go on and solve that. Next up, we're asked to solve this, and hopefully this works through. Some of these past questions can involve logarithms, so we'll work that out in a second. So notice how this is the same question from here. So I'm going to solve 2y squared minus 17y plus 8. Now, in order to help speed me up here, I'm going to use my calculator. So I'm going to go down to solving this on the calculator. Polynomial, degree 2. I've got 2 minus 17 and 8. So this is going to give me that y equals 8 or a half. Now I've got to keep in mind what y actually is. Y is 2 to the x, so I need to go back and solve that. So 2 to the x equals 8, which means that x is 3, or 2 to the x is a half, which keep in mind is 2 to the minus 1, so x is minus 1. So they're my two answers there. So that's 6 points, not too bad. Next up, we've got rationalizing, and we've got to show it in a certain format. So we've got surds, and we want to rationalize these. So we've got 2 divided by root 12 minus root 8. Now, the first thing I really want to do is to actually simplify these two surds. I'm going to resist, and I'm just going to go straight into the method. So I want to times top and bottom by root 12 plus root 8, which is the conjugate of the bottom. And that gives us a difference of 2 squares happening at the bottom here, which is really important for these questions because it gets rid of the surd cross multiples. So root 12, remember at the bottom here, this is in a bracket. So we're going to do root 12 times root 12, which is 12, and then minus root 8 times root 8, which is minus 8. So that's the bottom bit done. The cross multiples will cancel out. So we'll get 12 root 8 minus 8 root 12. So that'll just cancel out. 2 times root 12 is 2 root 12, and 2 times root 8 is simply 2 root 8. So we just want to kind of simplify this. Now, this bottom bit simplifies to 4, but both of these top are divisible by 2. So I'm just going to keep this as root 12 plus root 8 divided by 2. And then I want to try and simplify that top bit. Now, if I'd have seen ahead, if I'd have done it here, root 12 is actually, if we go through this, it's 2 root 3. And then root 8 is 2 root 2. So we're going to get this other 2 coming out here. Obviously, on this one, I've just got a plus instead. So I've got 2 root 3 plus 2 root 2 divided by 2. So when I divide by 2, I just simply get root 3 plus root 2. I didn't use my calculator this specifically because I want to get full points. So I want to show that I can do all of that. If I just put this on my calculator, it will tell me the answer. So that's how we go with that one. Next question. Let's have a look. Discriminant. Okay, so find the value of discriminant of f of x. Now remember, the discriminant itself is equal to b squared minus 4ac, not the square root. So here I've got a, b, and c. So 2, 8, and 3. the signs do matter as well, but all this is positive. So I've got 64 minus 4 times 2 times 3. 2 times 3 is 6, times 4 is 24. 64 minus 24 is 40. So that means this technically doesn't factorize because the square root of 40 doesn't exist. It's going to give me a, well, it's going to give me a third. It's not going to factorize nicely. So B, express this in a completed the square form. So this is completing the square. So the first thing for me for completing the square is to factorize out any coefficients of x squared. So I've got 2 and then x squared plus 4x. And I like to leave the 3 just floating at the end. It's up to you for this bit. So if you're leaving the 3 at the end, just keep in mind whatever happens inside this bracket is the only thing to get multiplied by 2. This 3 is just kicking around at the end here. So this is equal to 2 lots of, now completing the square in this bracket gives me x plus 2. So I half this number, square it, and I subtract that number squared, which in this case is 4. I'm just going to do that in one step. And then at the end, I'll have this plus 3. So here I'll get 2 times my bracket squared minus 4 times 2. So this 2 is going to multiply by this 4 as well. So that's minus 8. Minus 8 plus 3 is minus 5. So that's part B. Let's try and label these just so we've got it. Part C. We're told that the line y equals 4x plus c is a tangent to curve y equals f of x. Calculate the value of c. Now, if you've done calculus, you'll want to do this in a different way. I'm going to show you both ways just for now because it's either way is viable. Well, basically for a tangent, I'm going to use discriminant first to show you how to use this. For a tangent, it's only going to touch in one place. So tangent implies that it touches once. Now, I'll come back to that in a second. Two lines touch where they where you can equate them to each other. So two lines meet where these two lines are equal to each other. So I'm going to set 2x squared plus 8x plus 3. I'm going to set that equal to 4x plus c. So these are going to be the same at this point on the tangent because that's where they both meet. So I'm just going to rearrange this to get 2x squared plus 4x. So I'm taking away that 4x. And then plus 3 minus c. This is my constant here, equals 0. Now, this tangent touching once implies that the discriminant of this particular quadratic will equal 0. So up here, it implies that the discriminant is equal to 0. So if I work out the discriminant of this, I can then set that equal to 0. So the discriminant equals 0 implies, here I've got 16 minus 4 times 2, which is 8, times by this bit at the end, which is 3 minus c. So that's really important, and that's going to be equal to 0. So from this, I just want to find out what c is. I'm just going to put a line here and go up top. So I've got 16 minus 24, which is minus 8, and then minus 8 times minus c is a plus 8c, which equals 0. So here I can see, I take this across, that c is going to be 1. And that's what we're asked to find. The other way to do this, I'll just move my calculator out of the way. The other way to do this would be through differentiation. So because you know that these are going to have the same gradient, you know the gradient is 4, so you can find out where this is giving a gradient of 4. So you could do f dash of x is 4x plus 8. Where is this gradient equal to 4? Because this has got a gradient of 4 and it's a tangent. So 4x plus 8 equals 4 implies that x equals, and then find your x value. So taking away 8 from both sides here gives you that x is minus 1. Based upon that, you can find a y coordinate using your original equation, and then you've got a point to use to find this this constant. So there's a couple of ways of doing this. So if I put minus 1 into my original equation, I get 2 minus 8, which is minus 6, plus 3, which is minus 3. So something along those lines. If I put that now into y equals 4x plus c, and if I put these values into here, so minus 3 equals minus 4 plus c, I get that c equals 1. So either way of doing that, absolutely fine. I actually like the discriminant way for this. I found this a little bit nicer, but it doesn't really matter which way you go. Okay, last one in this particular kind of session. I'll do more of these shortly, but this is the last one from here. So it's another looking at this. Is it discriminants? Yeah, another discriminant. So how I'm spotting that is I just see this bit here. So the fact that it's got no real roots is telling me that the discriminant is less than 0, or yeah, it's basically less than 0 on there. So this implies that discriminant is less than 0 because it's got no real roots. So having a look at this particular thing, the discriminant itself. So this is A, this is B, this is C. So A is P minus 1, B is 4, and C is P minus 5. So the discriminant for this is B squared, which is 16, minus 4 times A, which is P minus 1, times C, which is P minus 5. And this needs to be less than 0. So we want to expand all of this and find out what's actually happening. So I've got 16 minus. This thing here, I'm going to keep the 4 for now, is P squared minus P minus 5P, it's minus 6P. And then minus times a minus gives me a plus 5. And that wants to be less than 0. Expanding all of that, I get 16 minus 4P squared plus 24P. And then minus 20. And that's less than 0. So when I come to flip all this around, everything divides by 4. 16 minus 20 is minus 4. So I get minus 4P squared plus, oh, I'm almost dividing here. Don't want any of that. Apologies. Let me just find my eraser. It's not working on there. There we go. Plus 24P. And then this bit here, as I say, was minus 4. So you want to flick it all across now to the other side because this is negative P squared and divide by 4. So dividing by negative 4, let's just do, I get P squared minus 6P plus 4. And because I divided by a negative, this inner bullet is going to flip. So it becomes greater than 0. Next bit is to find the possible values. I'm going to cheat and use my calculator. So I'm going to go down to option B, which is here. And I'm just going to put these values in. So it's a polynomial of degree 2. And I want strictly greater than, which is option 1. So I'm going to put in here 1P squared minus 6P and then a plus 4 at the end there. I put equals in. It tells me that X is going to be less than 3 minus root 5, or X is greater than 3 plus root 5. And that's okay to get those 4 points. To solve this properly, you should be considering the graph itself. So you want to find the roots, which are 3 minus root 5 and 3 plus root 5. And then you're looking at, once you've sketched the graph, so these are your roots, you're looking at where is this bigger than the x-axis. So it's here and it's here. And this corresponds to X being bigger than 3 plus root 5, because that's that root. And this side here is less than, because that's that root. Hope that helps. As I say, I'll do a few more shortly. The next kind of clip.